right now we are going to get into what we call combining functions. We will start off with an illustration here. We have functions, and a function called f and a function called g, with both of them having inputs as x. Now, these functions f and g can be combined. We can combine them by either adding them up, we can combine them by subtraction, we can combine them by multiplying them, we can also combine them by dividing them. So we'll start off with adding the functions. This is the notation. We shall first go through the notation. The notation here of some of the function, we have a function f and a function g. We call it f of x or g of x. Both functions have the input as x. So if we are to add them, it will mean that it's going to be f plus g. These are the two functions we are adding, and the input is both x. Adding this function is the same as saying f of x plus g of x, or the function f where x is the input, or the function g where x is the input. This is the notation. That is how we represent some of a function. Then we have what we call the difference of a function. Of course, the difference of the function here, we are subtracting the functions. The function f minus function g, where x is the input, this is one way of representing it. This is the same as saying the function f where x is the input minus the function g where x is the input. We can also combine functions by multiplying them, and in this case we are saying the product of a function. The product of the function in this case is representing by that dot, f dot g. F dot g, where x is the input variable, is the same as saying f of x dot g of x. In this case we are multiplying the functions. Then we have what we call the quotient of the function. Of course, the quotient in this case is that we are dividing the functions, where f divided by g, where x is the input. And when we divide those two where x is the input, we have, it's the same as saying f of x, divide that by g of x. But the condition here is that the function, whatever function is in the denominator, should not be equal to 0, because if this function is equal to 0, then it would mean that the quotient of the function would be undefined. So the condition is that this is only valid when whatever function is in the denominator is not supposed to be equal to 0. Then we have what we call the composite function. A composite function is more like you place a function in a function, and it is represented by that round dot. It is more of a dot, it is just more of a small round circle. That the function f, being a composite of function g, or f small round circle g of x, where x is the input, is the same as saying f, and in f into where the input is another function. In simple terms, a composite function is more of a function of a function, or it is a situation whereby you're having a function that is acting as an input in another function. So in this case, you'll see that the function g of x in this case is acting as an input of the function f of x. So we're having a function being an input of another function. So of course this is the notation, that f with the input g of x. Same with here, we are having the function g, and this function g is such that its input, or its value of x, or its input, is another function f of x. So right here we are having a number. We have that if f of x is going to be equal to 3x minus 2, that is a function f where x is the input, and that's the function. And then we have function g where x still is the input, is given by x squared minus 4. Write an expression for each of the following functions, and our value of a there is f plus g. We are supposed to add them. Of course, f plus g of x, this is the same as saying f of x plus g of x. So the function of x in this case here, according to our question, is 3x minus 2. So this is going to be 3x minus 2 plus our g of x. Our g of x is x squared minus 4. So we go ahead and add them and get our final expression. So this is going to become 3x minus 2 plus x squared minus 4. So this is going to become, we arrange the collect like terms, look at x squared plus 3x This is minus 2 and minus 4. Minus 2 and minus 4 gives us minus 6. We end up with a quadratic equation, and that's the answer. In part B, we are trying to find the difference of these functions. Of course, f of g of x is the same as saying f of x minus g of x. Definitely, this is going to end up being f of x, in this case being 3x minus 2, minus g of x. Our g of x is x squared minus 4. This is going to end up being 3x minus 2. Then we open brackets. Negative 1 times x squared is going to give us negative x squared. Then we have negative 1 times negative 4 gives us positive 4. That's going to become, of course, we collect like terms. This is going to become 3x, that is minus x squared. Then we have negative 2 here and positive 4. Negative 2 plus 4 is going to give us positive 2. So that gives us the answer. Or if I may rearrange this in the form of a quadratic equation, it turns out to be x squared plus 3x plus 2. Then we have here, we are multiplying the two. We have f dot g. This is the same as f times x. This is same as f of x. Multiply that by g of x. So this is going to become f of x. In this case, f of x is 3x minus 2. Multiply that by g of x, which is x squared minus 4. So definitely these are two brackets multiplying each other, so we are going to go ahead and open the brackets. So this becomes 3x times all these brackets, which is going to be 3x times x squared minus 4 minus 2 times, this is minus 2 times the whole bracket, minus 2 into x squared minus 4. So opening brackets, 3x times x squared is going to give us 3x to the power 3. 3x times negative 4 is going to give us negative 12x. We have negative 2 times x squared giving us negative 2x squared. Then we have negative 2 times negative 4 giving us positive 8. We go ahead and rearrange this to make it simpler. This becomes 3x cubed minus 2x squared minus 12x plus 8. And we can't simplify it any further than that. That's our answer right there. Then we have f over g of x. F over g, of course, this is more of, we are finding the quotient of these two. This is the same as saying f of x. Divide that by g of x. Dividing these two, we have f of x giving us 3x minus 2. Divide that by g of x. G of x is x squared minus 4. And I think that's pretty much it. It's going to give us 3x minus 2 over x squared minus 4. You can simplify this further. X squared minus 4 is the same as x squared minus 2 squared. This is difference of two squares. And difference of two squares ends up giving us 3x minus 2. Divide that by, this gives us x minus 2 into x plus 2. Difference of two squares, the property. So definitely, remember we said that when it comes to quotient, the key thing here is that the denominator is not supposed to be equal to 0. This is how we illustrated it here, that when we are looking at the quotient function, it is supposed to be such that the denominator, the g of x, is not equal to 0. So since here the quotient function is such that it is 3x minus 2 over x minus 2 into x plus 2, the condition here is that if I make x 2 here, if I make x 2, it's going to be 2 minus 2, this is going to be 0, and it will make this whole denominator 0. Likewise, if I make this x here negative 2, it's going to make this whole thing negative 2 plus 2, giving it 0. So it's going to make the entire denominator 0, and this function, the quotient function, would be undefined. So the condition here, therefore, we shall write and say that the value of x in this case is not supposed to be equal to plus or minus 2. That's the condition for this quotient function to stand. So looking at the final, it's a composite function where we have the function f times a small circle g of x. This is the same as saying that we are looking for the function of x where our input value is another function g of x. So what is our function of x, for example? Our f of x is 3x minus 2 right there. 3x minus 2. That's our function f of x, our function where x is the variable. And according to this composite function, if this is our function xf, it is such that the input value is another function. So it means that in this place of x, we're supposed to put there the function g of x. So this is going to become 3, multiply that by, in the place of x, we are putting g of x, which is this whole thing. So this is going to become x squared minus 4. That is what we are putting in the place of x, minus 2. And so we go ahead and simplify that. That is 3 times x squared is going to give us 3x squared. Then 3 times negative 4 is negative 12 minus 2. And we shall end up with 3x squared. Negative 12 minus 2 is negative 14. That's pretty much it. Then we have g f. Then we have gf of x. This is the same as saying g, small round circle, where the input of is f of x. So what is our g of x? Our g of x is x squared minus 4. Now, in our g of x, in the place of x, we are supposed to put another function called f of x. So in the place of x, we are putting a function. So that's going to become, in the place of x squared, our f of x is 3x minus 2. So we are going to put here 3x minus 2, that is squared, minus 4. And that's going to become, so we go ahead and expand this. This is definitely going to become 9x squared minus 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12 minus 12x plus 4. Then this is an expansion of this, minus 4. And so we shall end up with 9x squared minus 12x. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.